maintaining a 6-year-old Ruby project.
Here we go. So, alright, generally I'm super nervous when I'm on stage. And today even more, because I'm the only obstacle between you and this amazing beef. So, I promise I will try to stay within my 25 minutes boundaries. I just want to keep you far away from that. So given that I'm really nervous, I need to talk about something that I know really well. So I decided that today I will talk about scuba diving, given that Christoph already introduced the talk. Well, actually, I'm kidding. I just want to quickly mention the underwater Ruby project that we did before the conference, and specifically I want to thank you, the organizers, for making it possible. There was actually a joke that we made in Tropical Ruby 2015, and Chris was so serious to make it happen. So thank you very much for doing that. We had a lot of fun. That was announced during a few emails, but not a lot of people follow up. I hope that more and more conferences in the future will think about that. So thanks, Chris, for making it happen, and thanks for all the organizers. There's a Twitter account you can check, and I guess the other organizers can get in touch with Chris and maybe plan a little bit more for other conferences. Alright, so my talk is about maintaining a 6-year-old Ruby project. This is kind of a practical talk, and we have just 25 minutes, so I will not go too much into the details, so feel free to ask questions later on or just approach me. I will be more than happy to share more details. So some examples are not extremely visible, but the slides will be available for download, so you will be able to read through the code and probably and hopefully get a better idea of what I was talking about. The talk is divided into mostly 2 sections. In the first one, I will provide a little bit of context about the application and the examples I will use. And in the second one, I will talk about 4 different principles that hopefully will help you to design and write more maintainable code. Just a very super quick introduction. My name is Simone Carletti. I'm also a scuba diving instructor, beyond being a programmer. My account handler is, my nickname is Webpost, pretty much everywhere, Twitter, GitHub, and so on. I work for DNSimple. We do provide domain services and SSL certificates in DNS hosting. Now, we're a pretty small company. Although we're really active in the Ruby community, we provide services for a lot of great services and tools such as Ruby Gems, Travis CI, and even Atom, the GitHub editor. So probably if you use any of those tools, you actually use our services. So thanks for doing that. I want to start quickly talking about what I call the cycle of maintenance. So day 1, world is beautiful. You have a small race application with a few gems. Actually, a disclaimer, this is not a talk about race, but it will include some race code, of course. So again, day 1, world is beautiful. But then, after 1 year, your app is getting bigger, you have more gems. Still, your code glued together pretty much quite nicely. Year 2, things start to get a little bit more worse. You remove dependencies, and because Ruby doesn't scale, you have to introduce different technologies. So yeah, things start to get a little bit iffy. And then year 3, your application will start to fall apart. Sometimes applications don't even reach year 3. They just fall apart before approaching year 3. We're pretty lucky. We are year 6 so far, and there's a reason for that. And we're trying to share my knowledge today. After year 3, sometimes just game over. So you have to start from scratch, or move to a different language, or start again. Super simple, architecture design of the DNSimple, part of the DNSimple infrastructure. We have several different languages. The core is mostly a Ruby application. It was a monolithic app in the past. It's still a pretty large monolithic Rails app, but we have more and more technologies inside, specifically Anami, which is the Lotus framework. I will talk about that later on, Sidekick. And then we have some Go inside our application itself, plus the majority of our like other services are designed in Go and our name server are written in Erlang. So we are really polyglot shop. So how much is big? It's really hard to find a reasonable, measurement. And personally, I think that lines of code are generally useful only when you have to interact with project managers. But I didn't really find better proposals or better ideas. So what I did is that I used Cloud to measure the amount of line of code we have in our application. As you can see, the main app has, mostly the entire app is about Ruby code. We have, of course, templates, JavaScript, but 2,500 files out of 3,200 files are Ruby files. We have some Go code, but it doesn't show here because we compiled that and we shipped that into binaries. If we run reg stats, we have, so it's interesting to see that our library folder is actually the biggest amount of code we have, and this is not by coincidence. I will explain that later on in my talk. So the controller and the model folders are really small compared to the rest of the application, we have a lot of spec. We have huge test coverage. More than half of the code is composed by test. So how can we keep our code maintainable? Here's a couple of concepts that I want to mention. The first one are convention. So agreement to me is probably the best explanation for convention. You can find several different explanations, but agreement to me is the most important one because agreement means shared knowledge among your team. And that's really, really super important. So you want to make sure that your code is consistent and easy to maintain from any team member, not just from you. So conventions are important to make sure that the entire team speak the same language. Now, my question here for you is, have you ever formalized your code style for your other team members? That's really, really super important. So we do. We have a wiki, an entire wiki, not just a wiki page, an entire wiki where we share convention about our code. And specifically, you can see that here we have some what we call code guide, where we essentially document a bunch of patterns and ideas we use throughout our code. Maintaining such documentation is hard, we know that, but the cost is well paid in the long run, especially when you have new developers jumping into the project. There are other code conventions, so you can see, for example, the GitHub Ruby style guide, and another one pretty famous is the Ruby style guide. And from the same from the same author of the Ruby style guide, you have RubyConf, which is a pretty nice project. I was honestly reluctant to use it at the very beginning. I thought it was really annoying. But since I tried that, I was really pleasantly surprised. So I encourage you, given it's extremely configurable, I encourage you to check it out and try to think about using something like that in your code. The nice thing about RubyConf is that it will automatically apply the convention to your code in most of the cases. So even if you make write your code a little bit differently, that will reformat your code. So it's pretty amazing, especially for someone like me, used to Go format. My tip is just to try to be too picky and enforce super annoying convention. Otherwise, you will all the team will hate you. Another thing I want to talk about is patterns. I'm not talking about design patterns. Some of you are probably familiar with the idea of design patterns. This is something a little bit different. I'm going to give a couple examples. So the first kind of pattern I want to talk about is text patterns. So to me, homogeneous text and names are easier to search and refactor. Well, just to me, but I really care about that. So this is one of the examples. I hope you can at least get an idea of that. So here I have a commit where I change, I made a super trivial change. I change handle successful request to handle successful request in order to keep the code consistent across all the tests. Now, that seems super silly at the beginning, but I have to tell you that when you will have, after a couple of years, to refactor your 3,000 lines of code from mockup to RSpec, that will be really, really useful. Okay, so it's really important in the long run to even use the same terms and the same names. Another thing I really care about are code fragments. So recurring behaviors or code fragments can become code snippets or later on be extracted. So this is another example. Here I made a change where even if we have code that was pretty much similar but was not using the same names for the methods, I made a change to make sure that it was using the same convention and names. That will help because if you have identical code, that will be easier to be spotted, especially by static analysis. Sometimes it's just not ready for extraction, and in fact, in a few cases, I believe that small code duplication is better than premature extraction. But it's important to keep the same naming because that will be easier to be spotted when you research and dive into your code. Just a quick example of what happened when you don't follow the convention. This is part of the huge refactoring I made to switch from Mocha to RSpec mock. What happened here is that I was using some regular expression to update some code, and accidentally some of the spec were broken because by doing the replacement I actually changed the string description into a method call, and that was because we were not using the same strings between in the different descriptions. So that's really important when you have to maintain your code in the long run. So patterns are useful to promote code reusability, improve long-term maintainability, and of course speed up code refactoring. At this point, I want to just mention 4 principles that, this is the second part of the presentation by the way, 4 principles that for me should drive your daily development. The first one is experiment. So sometimes your code is not ready for extraction. This is one of the key topic, the key principle in the end simple. We constantly experiment. I mean, sometimes you know that something is wrong, but it's not immediately evident. So what you have to do is try to find a way. My first tip is stand up. So when you make an experiment, write code that the team members will notice. So here, for example, I have an example where I originally was using a non-Ruby standard way to define a method. So it's an underscore method naming. And now that worked because originally when I was making the experiment, nobody on my team cared about that. They had, more important things to care about. But the more the people were coming across and stumbling upon that specific line of code, the fact that it was not really Rubyist, was they started to ask me, what's going on there? What are you doing? And that's the time when they were ready to understand what I was doing. So by using strange symbols, even emoji, I don't know, that will actually make your code more visible to the other developers. Another thing I really love is to use stupid names. That's awesome, especially when you see the reaction of your coworkers. I mean, I say stupid names, not stupid code. But stupid names catch the attention of the other fellow developers. So here's an example. I was making a transition from a single user application to a multi-account application. It's like changing the base of a ship when the ship is sailing. It's not really that easy. So in order to make sure that we were not building other customers by mistake, I created a kind of security measure and double checks to guarantee data integrity. And so I had to raise an exception that was clearly visible because we had to immediately take action on that. So what I did, I used a name. I don't know if you can see that, but the name is should not happen error. So when more and more exceptions will flood into your Slack channel, people will start to get used to them and ignore them. But when you see something hey, I should not happen error just happened. What's going on? Yeah, that was pretty funny. So I blame the guy who ate sushi. So that's a great way. Just stupid name all around the world. I was actually thinking last day about refactoring the code and started using team members as opposed to class names. Like Anthony controller is spawning a new Antoine process, but probably that was too much. So the other thing that you have to do when experimenting is measuring. This is something that Aaron was mentioning yesterday about measuring bottleneck for optimizing your code, and that's pretty much the same thing. So is a change really introducing quality? So So here's a very simple example. I know you can read the code. I will try to go through that, but again, the slides will be available. So here's a change where we had to share the parameters. So we were using strong parameters in the past, and we have to share those parameters across different components. And we wanted to have a solution that was not race dependent. So we wrapped that, and rather than using concern, we created a params object that we could reuse in several different parts of our code. So that change was reducing a lot of the duplication. It was increasing the test, the ability to test the code. That's pretty much how a param object looks like. So we have a base param capability. We have explicit behavior, which is called the params allowed. So we can have different kind of whitelists. And then we have the concrete implementation, which is, for example, the contact parameters, where we use the behaviors we want, like, for example, params allowed, and which are the list the parameters we want. Now, the nice thing about that is that we will decrease duplication, and at the same time, we will increase the ability to test that, because it's way more easy to test a new object rather than just testing a concern. And so, how did it work? Well, actually, it worked pretty well. This is a code climate screenshot. So by running code climate on our application, so that was doing static analysis, we saw that a bunch of classes jumped from D or B to A or B. Okay, so that was a huge improvement, really huge improvement. I mean, don't blindly trust static code analysis, but I mean, when you have so many A and a lot of green going on, you know, that's beautiful. Okay, great. So, but unfortunately, it doesn't always work like this. Sometimes you fail. It's normal. Experiment may fail, and it's okay. But you should learn from failure. Now, the first thing I want to warn you about is beware of mixins. They can be so dangerous. I already started mentioning that. Now, to me, pulling out methods from a large class into mixins, in some cases, most of the cases, it's like hiding the dust under the carpet, especially if the specific part of the code is used just in one single class, you know. I mean, it looks cleaner at the surface, but it actually makes harder and harder to inspect your code, especially after a few years, and understand where you can extract things further into objects. So think about that. This is one example where we failed pretty badly. We had a concern mixin. And so this is a worker object that connects the Ruby application to the Golang processes that exchange the zone updates. And so we, rather than creating a client object, what we did is that we extracted part of the logic into a mixin, and we just mixed that in all the workers that we were using. But that was really cumbersome. And by creating a simple zone client, zone server client, which is a simple HTTP client that talks to our zone server, we were able to isolate the dependency, and the improvement was really huge. So, I mean, I don't know who came with this quote, but this is pretty awesome. An application with app concerns directory is concerning. I wouldn't comment on that, but okay. So, I mean, in most cases, it's better to use a completely new object. I mean, the story here is that we are not afraid to be mistaken. I can share with you so many cases where we failed pretty badly, but we learn from the experiment. And of course, we are never afraid of being wrong. So even like during this presentation, if you don't agree with something, I will be more than happy to talk about that with you or share, I mean, more ideas. The last thing I want to talk about, which is really important to us, probably one of the most important concepts, is abstraction. You have to be in control of your code in order to maintain your code. And yes, I'm sorry, but as a developer, you have to write code. It seems that Rails and Ruby developers are really afraid of writing new code, creating new classes, but hey, that's your work, okay? And it's absolutely fine. So, in the end simple, what we do is that we have a custom API. So pretty much any external dependency we introduce, we wrap that behind a custom API. So that's why, for example, the library folder is so huge, because we write majority of the code we use. That's a super simple example. So at some point we had to validate phone numbers, and we introduced the dependency to the phony library. format and validate the phone numbers. And rather than using phony directly in our code, what we did is that we create a simple simple phone module in this case, and we use that consistently across our source code base. Now, a few months later, we realized that phony, so numbers were so complicated that phony couldn't have all the definitions, and we had the need to introduce the whitelisting exceptions. So we just introduced a hash, and we made a few changes to make sure that the whitelist was properly used inside the library, but we didn't have to go through every single place in our code where the library was used and change that. You know, we will have to do that if we were using phony directly. Instead, we just make one single change here, and the change was super trivial. So, by using custom API, side features or extension can be introduced without an extensive change to the code base. Incompatibilities can be addressed in a single place. When and if needed, the external dependency can be replaced. So, you know, you can just change in the underlying dependency because you don't really use that directly. And another really important thing, testing doesn't require extensive stubbing because you can have your own test implementation, even like have a test adapter and then copy that directly rather than having to stub other gems that you have no control. One special mention here is Active Record. We have special conventions and guidelines because it can be pretty tricky to deal with that. So for example, just a few ones. Methods defined in Active Record base are not allowed to be used outside the models. Okay, so we don't use like where or find outside the models. We don't chain them in the controllers like most of the race guys. Models must expose custom API for every single operation. Callbacks are not allowed anywhere in the code except for data integrity. Query methods like again where, find, and so on are not allowed outside the model, but we use instead what we call finders. It's a custom object that we created that wraps this kind of behavior, so that we don't have to override REST Active Record defaults and then like de-override when we don't need de-override. Then scopes can be invoked directly outside models or finders, and they only exist to support finders. This is an example. I won't go through that, but I mean, feel free to check it out in the slides. And if you have any questions, there's a lot of like real use cases here, like the fact that in some cases we need to have modifiers from the input. In other cases, we need to gain control of the find, which is generally a specific kind of method. I mean, different models may have different find behaviors, you know. Now, these guidelines are the result of years of experiment and discussion. So I really want to thank the entire DNSimple team here because I personally learned a lot from them, and they've been extremely supportive and open-minded, especially when I proposed, or let's say forced, some new ideas or convention that at the beginning sounds like crazy, but in the long run they work it. Sometimes I also feel pretty badly, you know. We're all human beings, but I mean, they're being really supportive, so I really want to thank you, all of them, for being so awesome. Ending on the talk, I want to just you to put aside a little bit the information you got so far. I want to quickly describe our infrastructure in the main application. So we have, to show you how this concept can apply in a real-world project. So we have, this is our application mostly. Here you can find models, and here you can find controllers. So you can see we have a lot of things in the middle. So we have controllers, generic controllers can be like Anami controllers, Lotus, or Rails controllers. Then we have commands inside that maps every action that the user can do. And then we have services that are like a single unit of activities. Now our models are just persistency. So for example, you see that in order to enable or disable a zone, we have a flag that will persist the configuration on the database, but it's just turning on a boolean. What will happen is that the majority of the logic will happen in other places like domain services that can be reusable and composable. Special mention to Anami here. This is a pretty good framework made by a friend of mine that was called Lotus in the past. We use that for redesigning our new API. I really encourage you to have a look at that because it has some really interesting principles, especially for testing and code reusability. And I want to show you an example of a control, how all those principles like custom API allow us to be able to reuse our code. So this is a controller in Rails, and this is a controller in Hanami. As I mentioned, we started to completely rebuild our API version 2 in Hanami rather than having them depend on Rails, but they still share the same Ruby code base. So we have the command, and this is a domain area, so one of the most complex in our application. We have a command which is reused consistently in both controllers. So for us, the controllers are just like an entry point, you know, and all the rest is like custom objects that don't have any specific dependency to either Rails or Hanami, and that's it. That's really the whole code that creates a new domain. So I mean, it's pretty slick and really easy to write. In Hanami, every action is actually a class. This is pretty good because you can easily test a specific action just by instantiating the class and by like writing real unit testing. So again, I encourage you to check it out, and I will be more than happy to share more code with you if you want to do that. Wrapping up my presentation, first of all, don't be a code monkey. Just don't do that because I say that it worked for us, but experiment, okay? So don't take my word for it. Fail, it's okay, be ready for that, learn from failures. And then another suggestion, like small steps, don't throw away the entire code base today because you feel that this one is better. Pay attention to code smells. Metrics cannot really be always super useful, but sometimes they are useful to start to understand whether something is going wrong. I mean, Mark yesterday, I think it was Mark, mentioned about broken windows. So that's a kind of metric. You know, you have to be aware that something is going wrong because when it will be really wrong, it will be too late. The last thing, be influenced by other programming languages. This is probably my most favorite tip. In the last 4 months, I wanted to rewrite completely the API in the last couple of years. In the last 4 months, I worked in parallel to develop official clients in 4 different languages in parallel, almost the same day. So I was writing Ruby code, Go code, and Elixir code, plus in PHP. And I mean, by having to use different languages, I became a better Ruby programmer. And so this is not a coincidence that, for example, I use Go as a primary language because it was harder to implement certain things in Go. And by understanding that, it was better for me to provide better Ruby code that could be used by other different languages. Finally, start today. So don't wait. I mean, small changes every day makes a huge difference. And this is the credits for the pictures I used, and thank you, everyone.
We have time for one question. Yeah, go ahead.
Hi, good afternoon, Mark.
Hi.
I just want to say your talk was really awesome and
Thanks.
very much needed for most of us here. But I want to get an insight of, I think, you mentioning that wrapping an external dependency into your own custom API is like genius because it's going to save you time when the API shifts or moves forward to a new version. And I think the same can be said with the active record model methods being wrapped around in another class. But I just want to get an insight of whether you have experience testing this. Is there like a penalty in terms of speed, performance, or something like that? Just because I can see the pros, but I don't know if there's a con, if you've already seen it.
Well, the major cons I would probably outline is the development cost. So it takes a little bit longer to get there, and it doesn't always make sense. So you always have to use your brain and judge and balance when it makes sense, especially if you are consulting versus you're building your product. You know, it's largely different. So this presentation is focused on maintaining a code base. It could be a small one, large one in the long run. So if you're just consulting for shorter periods, sometimes it doesn't really make sense. Or your customers, your client, won't even buy that because they just want the product right, I mean, there's no really speed penalty. Honestly, it's mostly like the war between using single quote or double quote. I mean, the difference is so small that there are actually other areas where you can get much more improvements, So the benefit that you can get by writing a more maintainable code in the long run is nothing comparable to possible small performance issues because you have to inject one more method call into the stack trace. So honestly, I don't really care about that, and I would recommend to not just bang your hand against the wall trying to say like, hey, one less method. So I mean, let's write 40 lines here, lines of code methods, because that way we don't have to call different methods. Again, there's always a balance, but I really feel that if you want to foster performance, there are other places in the application where you can really do that. Like, Charles was talking about threading, multi-threading, and so on. So that's, for example, one possible solution if you have specific problems where you need different kind of performance. I hope I answered your question.
Thank you very much.
Thank you.
Thank you, Simone.
So you can now have your